Alright, one of the story problems or word problems that tends to plague a lot of math students is when we're talking about consecutive integers. And so here I wanted to just do a couple additional examples talking specifically about consecutive integers. Okay? So, consecutive integer is an integer next to each other. In other words, if you started with one integer and you add one every time, you have consecutive. However, we can also add things specifically in terms of odds or in terms of evens. Therefore, if you're doing odd or even, it would be the same as if you were adding 2 to your number each time. Okay? That's really the biggest thing that you have to remember. You just have to know, what are you dealing with? Are you dealing with consecutive, or are you dealing with the even or odd? So here I have, find two consecutive integers whose product is 110. So I want just consecutive. So this means I am looking at the definition of n plus 1, n plus 2, n plus 3, etc. So I'm going up each time. Now I have to look at how many do I want. Well, in this case, I only want 2. And of those 2, I want to know that their product is 110. So in other words, again, this means to multiply. So we have to look at how to set that up. So I need two consecutive integers. So I'm looking at having a first integer and a second integer. And since I don't know what they are, according to the definition, my first integer would be whatever I started with. My second integer would be what I started with plus 1. So now I need to look at what exactly is my problem saying. And again, we're talking about the product. So I'm talking about taking my first integer and multiplying it by my second to give me 110 as a result. So here, in order to do that, you need to substitute n. So this is going to end up being n times n plus 1 is equal to 110. Distribute that n through so we can solve. We end up with n squared plus n equals 110. We need to use standard form, so that means move the 110 over, so this becomes n squared plus n minus 110 is equal to 0. And now I need to solve. So one of the things that I have to look at is I have to look at the information provided. So what do I have? Well, this negative here tells me that I am going to use the factor option, positive times negative. This plus sign here tells me that I am going to use the concept that my bigger factor is positive. And then the last thing I have to look at is I need to have my factors of 110. So here we go. We know that we have 1 and 110. We're going to have 2 and 55. Five and 22. And then we have 10 and 11. Now again, my bigger factor is positive. So all of these factors on this side here are going to be positive. Means all of these, the smaller ones, are negative. And I need to know a combination of these that is going to give me a positive 1 as a result. So here, I have positive 11 and negative 10. So when I'm looking at it, I can create my factors. So here I'm going to have n minus 10 times n plus 11. And this equals 0. Solve each of them. So I have n minus 10 equals 0 and n plus 11 equals 0. So I have that n equals 10 and n equals negative 11. So I have two options here. Well, I have to look at them both. So, first of all, I have option 1. Option 1 says if my first number is that n equals 10, then my second number is going to be 10 plus 1, which equals 11. I then have option 2, which says if my first number is that n equals negative 11, then my second would be negative 11 plus 1, which equals a negative 10. In both scenarios, whether you have positive 10, positive 11, or negative 11, negative 10, you both come up with 110 as an answer. Now, since your sentence here does not specify positive or negative, both solutions are required. Okay? So when we're talking about then the solutions that we had, we would have to include both options as our viable solutions to our problem. Alright, let's look at a different one. So here I want to find 3 consecutive odd integers. So just that particular fact says that the definition we are going to follow here is we're going to start with a value, but then to get odd we have to add 2 each time. Okay, so that's the definition that we have to follow here. So we're going to follow this such that the following holds true. The product of the first and third would be your equal sign. And then I have more than is that turnaround phrase, which says the second part here, 10 times the second, has to go first in reference to that 71. So here I've got my 3 integers. I've got my first, I've got my second, and in this case I've got a third. So if I start out with n, because we're looking at odd, this becomes n plus 2, and the bottom becomes n plus 4. So now we need to set it up again. So the product of the first and third. So this is talking about my first integer times my third is equal to 10 times the second. So 10 times the second plus 71. So 71 more than 10 times the second, that's your turnaround part. So this back part comes first, the 71 goes last. More than says that we are doing addition. So now that we've got a roadmap here, we need to actually plug the information in. So this is going to be n times n plus 4 is equal to 10 times n plus 2 plus 71. Once you input all of the pieces, now is where you solve. Distribute the n through. This gives you n squared plus a 4n. Distribute the 10 through, and you get 10n plus 20 plus 71. These terms on this side can be combined. So I have n squared plus 4n is equal to my 10n plus 91. I need standard form, so everything on this side here is going to move the other direction. So I'm going to have n squared minus 6n minus 91 is equal to 0. Again, I can look at what it is that I am being told. So this first sign is going to tell us that we're going to use positive times negative. This back sign here is going to tell me that the bigger factor is negative. And then I need to have my factors of 91. So this is 1 and 91. And then I have 7 and 13. So here I have to look again at my bigger factor is negative. So these two numbers here are negative and my front factors are positive. And I need it to come out to be negative 6. So here 7 minus 13 is going to do just that. So when we look at it, this is going to tell us that we are going to have n plus 7 times n minus 13 equals 0. So solve them both, and we get that n equals negative 7 and n equals 13. So again, if we look at this, it does not tell us anything about this required sign. So I have these two options, which means both options have to be taken into account. So first of all, I have my first option, and that first option says if my first integer is a negative 7, then my second is going to be negative 7 plus 2, which gives me a negative 5, making my third negative 7 plus 4, which gives me negative 3. That's my first option or first solution. My second option is that my first integer is equal to 13. If that's true, then my second is going to be 13 plus 2, which gives you 15, making my third 13 plus 4, which gives you 17. Now a lot of students say, hold up, wait a second, why is it that we have two sets of options for this that works? And the reason for that is this. We're working with a quadratic equation. Quadratic equations have two possible solutions that yield correct results. Alright, so let's go ahead and look at this last one here. Here I have that we need to find two consecutive negative integers such that the following occurs, and we have 6 times the first plus, so this right here is your operation, plus the square of the second. So square of the second, and then here's your equals 34. So again, if I'm looking at it, I'm going to have a first and I'm going to have a second. And here I want consecutive negatives. So when we're looking at that, that still means that the definition we're going to follow is n plus 1, n plus 2, etc. Because I'm not talking about even or odd, I'm just talking about negative. So here my first term is going to be n, my second is the n plus 1. And so here I can now put it together. So 6 times the first, so 6 times my first, plus the square of the second, so this is the second squared, is equal to 34. Input what I know, 6n plus n plus 1 squared equals 34. I need to square out this n plus 1, so here I'm going to have 6n plus. This is going to give you n squared plus a 2n plus 1 equals 34. I need to combine my terms here, and I need to take this 34 and move it. So this is going to become n squared plus my 8n minus 33 is equal to 0. So again, I need to solve. One more time as a reminder, this back term here tells us that we are going to use the positive times negative option. This first term here tells us that the bigger factor is positive. And then I need to know factors of 33. So when I'm looking at 33, we have 1 and 33. We also have 3 and 11. Of these, the bigger factor is positive, so the bigger one's positive, the smaller one is negative. And I need to know which combination gives me 8. Well, 11 minus 3 will do just that. So therefore I can write my factors here. So we're going to have n minus 3 times n plus 11 equals 0. Set each factor equal to 0 and solve. So n equals 3 and n equals negative 11. Now in this case, again, we need to refer, and I'm looking specifically at the negative. And because of that, that tells us that using n equals 3 cannot work. Therefore, the only solution we have is that n is 11. So therefore, when we're looking at our solutions, if n is negative 11, then my second is negative 11 plus 1, which is negative 10. So here we have that the only solution is that my first is equal to negative 11 and my second is equal to negative 10. So there you have it. You have 3 different examples of working with consecutive integer problems. If you have any questions, please let me know. Otherwise, I hope you enjoyed. Remember to read each sentence very, very carefully and pick out the information provided. And I'll see you next time.